my today's session on electromagnetic field, and today we will discuss the Poynting Theorem. Myself Dr. Sayanti Chatterjee, Associate Professor of EEE Department of Institute of Aeronautical Engineering, Hyderabad. So before Poynting Theorem, we will discuss what is the electromagnetic wave. Electromagnetic wave, also called the electromagnetic radiations, are basically defined as superimposed oscillations of an electric field and the magnetic field in space, with their direction is the perpendicular to both of them. You can see here that this is the blue one is the electric field and the red one is the magnetic field. Two fields are superimposed and then we will get one electromagnetic wave. So electromagnetic wave, also called the electromagnetic radiations, are basically defined as the superimposed oscillations of an electric and magnetic field. When both are superimposed, they will create a new field, and this field they are used like if electric field is E, it is superimposed on H and it creates a new wave, and this wave is known as the electromagnetic wave. So electromagnetic wave is a cross of two vectors. One is the electromagnetic field intensity, one is the magnetic field intensity, and the direction of the electromagnetic wave is the perpendicular to both of them. And you can see this is the wavelength we are writing by nu. So what are the properties of the electromagnetic wave propagation? First of all, the wave travels at the speed of light. When any wave goes on in space, there are two things. One is mu naught and one is the epsilon naught. What is mu naught? Mu naught is nothing but the permeability of the medium, and epsilon naught is nothing but the permittivity. 1 by mu naught and c naught. If we put the value, will come the c. C is the speed of light. C is nothing but the speed of light. So when the electromagnetic wave travels in a free space, its speed is the speed of light. These waves do not require any medium for propagation. It can no need of any medium. Without any medium also electromagnetic wave can propagate. Electromagnetic waves always travel in a transverse form. It has a PEH sin theta, so it always went in a transverse form. The electromagnetic waves are not deflected by any electric field or magnetic field. Electromagnetic waves, when it is moving through any medium, it will never deflected by any electric field and magnetic field. These waves can be polarized. If we keep in a electric field and we give this, if we send this wave, it can be polarized. The positive will go to the positive and negative poles will go in one side. Similarly, the north poles will go in one side and south pole goes another side. So it can be electromagnetic wave can be polarized. The electromagnetic waves undergo interference and diffraction. If the wavelength is lambda and the frequency is nu, then we can write the speed is equal to lambda by nu. C is the velocity, not speed, velocity of the wave. As I told in the first class, the difference between the wave and velocity is wave has one. Wave and velocity is the speed and velocity is, speed is a scalar quantity. It doesn't have any direction, but velocity is a vector quantity and it has certain direction. So this is the electromagnetic wave propagation. What are the modes of the propagation? The modes of the propagations are, first one is the electromagnetic waves are propagated from the transmitter antenna to the receiver antenna in four parts. One is ground waves. When the electromagnetic waves are propagated along the surface is known as the ground wave propagation. It is known as the ground wave propagation. The waves are going propagated along the surface, along the ground. It is called the ground wave propagation. So electromagnetic, if we are talking in a phone, if the sound wave becomes the mobile wave is the electromagnetic wave. So there is a transmitter. While we are talking, it takes the transmitter antenna. Or you can think about a TV. In a TV, while we are watching a picture and listening the sounds, it is coming from the transmitter antenna and from the satellites. And in our home, there is the receiver antenna. So receiver antenna takes this. So this is the mode of electromagnetic waves propagation. And the first one is the ground waves. When the electromagnetic waves are propagated along the surface, the propagation is known as the ground wave propagation. Next one is the space waves. When the electromagnetic waves propagate from the transmitter to receiver antenna without any reflection and refraction, the propagation is known as the space wave propagation. Wave space in the free space. So this is the space in the, this is the normal wave propagation. And last one is the sky wave propagation. When the electromagnetic waves are propagated through the sky and get deflected back to the earth, the earth from the ionosphere, this is known as the sky wave propagation. So next we will discuss the Maxwell's third equation. Already we have discussed Maxwell's third equation many times. Just on quick review, from the Ampere circuital law, we can write that the integration of H dl is equal to di. And Maxwell's third equation and fourth equation both are based on the electromagnetic rule, and this is the fundamentals of the electromagnetic wave. So Ampere circuital law, we got the integration over a closed surface H dl is equal to I, and we also know that the J ds is equal to I. What is J? J is nothing but the current density is equal to di by ds. So I is equal to integration of J ds. So these two equation can be equate. These two equation can be equate, and this is known as the Maxwell's third equation in integral. Integral from. Now we are using the Stokes theorem because one side is dl, another side is ds. We cannot equate the both. So how to change from dl to ds? From the grad cross h. Grad cross h. So grad cross h ds is equal to j ds. So we can write grad cross h is equal to j. And if we want to, this is the current density in a conductor. But in the practical case, there is some dielectric medium. So what we got there, grad cross h is equal to j plus dd by dt, where dd by dt is nothing but the, so while current I is changing the flux through a surface produces a circulating magnetic field around any path. Electric current changes in the electric fields are proportional to the magnetic fields circulating around the area. So if this is a current, it is a circulating area, so it is the proportional to this value. And we can write the modified equation is the grad cross h is equal to j plus del d by del t. What is the del d by del t? Del d by del t is nothing but the displacement current density. Actually, grad cross h is, this is the conduction current density. Those from the Ampere's law, we know grad cross h is equal to j. But for the modified law, we can write grad cross h is equal to j plus del d by del t. Where del d by del t is nothing but the displacement current density. When current flows through any conductor, there is some displacement current always. So already these things we have discussed in my last class also. This is just a quick recap of the last class. For any details discussion, you can check my last class also. So now we will discuss the Maxwell's fourth equation. What is the Maxwell's force equation? You can see this is a north pole and south pole. If we move if there is a rate of change of flux, there is a rate of change of flux means according to the Faraday's law, the EMF will induced. So EMF E is equal to minus d phi by dt. Why minus? According to the Lenz's law, if there is a the direction of the EMF will be such that it will oppose its cause. So that's why the cause of the EMF is the rate of change of flux. That's why this minus came. So E in EMF or the voltage is equal to minus integration d phi by dt. What is flux? Flux is nothing but the B into ds. What is B? B is nothing but the flux density, the magnetic flux density. So whenever there is a rate of change of flux minus integration of V ds by dt. Again, from the electric potential we can write E is equal to integration of E dl, and if we equate the two sides, integration of E dl is equal to minus dV by ds. So this is the, what is this? This is the second integral form of Maxwell's equation. Integral form of Maxwell's equation. Now it is dl and this is ds. How we can change? We can change by the Stokes theorem. So E dot dl can be written as grad cross E. So if we equate the both sides, we will get grad cross E is equal to minus del B by del T. So what are the assumptions we are thinking? Changing the magnetic flux to a surface induces an electromotive force in the boundary path of the surface. We are assuming that the EMF is only at the boundary path. The changing the magnetic field induces a circulating electric field. The voltage accumulated around a closed circuit is proportional to the rate of change of flux. A circulating magnetic field is produced by an electric current and electric field that changes with time. So these are the four assumptions. Now we are coming to our main segment. What is Poynting Theorem? Poynting was a scientist who gives his theorem states that the rate of energy transfer per unit volume from a region of space equals to the rate of work done on the charge distribution in the region plus the energy flux leaving the region. So it is based on the energy conservation rule. The rate of energy transfer, when we are talking, this is an electromagnetic field, so the rate of energy transfer per unit volume from one region of space, what is this? Equal to the work done on the charge distribution in the region. So energy is equal to the work done plus energy flux leaving the region. We can assume like this. Say this is one region, the energy is coming out is used for two parts. One is work done plus one is the energy out from the another surface. So this is one surface, this is another surface, and both will be equal. And this is the Poynting theorem. Based on this, Poynting gave one more law. What is the law? When the Poynting vector named after John Henry Poynting is used in order to demonstrate the energy flux density of an electromagnetic field. So what does the Poynting theorem, Poynting vector told? Poynting vector told that the energy flux density of an EM field, as per the definition, the Poynting vector is the result of the vector product of the field's electric and magnetic components. Is the product of the field's magnetic and the magnetic components. we can write it if one is the S, another one is the E. So Poynting theorem generally written by P is equal to E cross H. E cross H. Sometimes the Poynting vector is written by S. P or S. We can write by both. Sometimes it is written by P, but as P is the P defines the polarization, so sometimes it is written by S. So P is equal to E cross H, or we can write S is equal to E cross H. What is the direction of P? It is always perpendicular. It is always perpendicular to the EH plane. If E cross H makes a plane, S is always perpendicular to the EH plane. It is always perpendicular to the EH plane. It can be rewrite as E cross B by mu. As H is equal to B by mu, the S can be rewritten as the E is equal to B by mu. Now we will discuss the proof of the Poynting theorem. So before starting the Poynting theorem, we will use the three Maxwell's law. The first law is divergence of D is equal to rho V. This is from the Gauss law we got, but we know that the in the free space number of charge is equal to 0. We know in the free space charge is 0. So the modified Gauss law from the free space can be written as grad dot D equals to 0. It can be written as, so for the free space we can write the current density J is equal to 0. J is equal to 0 means volume charge distribution rho V is also 0. In this, permittivity is epsilon naught and permeability is in the mu naught. So what is the modified Maxwell's equation? The modified Maxwell's equation tells the first equation grad dot D or grad dot D or grad dot E is equal to 0. From the Maxwell's second equation, already it is not modified, it is the second equation only. Grad dot B is equal to 0. For the third equation, we are using grad dot E is equal to del B by del T, and grad cross H is equal to, what is grad cross H? Grad cross H is equal to J plus del D by del T. But generally in the free space the J is 0, but for Poynting theorem we are not thinking current is 0. We are just using the Poynting theorem. So what we got from the first equation? First equation we got grad dot D is equal to 0. Grad dot B equals to 0. What is next? Next we got grad cross E is equal to minus del B by del T. We got it from the Maxwell's fourth equation. Now what we will do? We will take the, and what we got another equation, grad cross H is equal to J del D by del T. What is B? B is the magnetic flux density. What is D? D is the electric flux density. Now we are using this equation. We are taking the this is grad cross D. So what we are doing here? We are taking the scalar product of H into E. So what we are doing here? So we are taking the H into both sides. We are doing the cross product in the both sides. So it is minus H cross del B by del T. We have taken H cross, as this is an electromagnetic field, we are taking the both side curl. So H, we are taking H in the both side, and we are using the H grad cross E is equal to minus H del B by del T. Similarly, in the opposite side, I am writing with the another ink for it is the H means magnetic field density. We are multiplying it with the E. So electric field E cross grad cross H is equal to, we can taking the E dot J E. Okay, we are taking the not what thing? We are taking the dot product. Okay, then it will be easy. E dot, so E dot J plus E dot del D by del T. So we are taking the dot product. This is an electric field. We have taken the dot product of H. It is a magnetic field. We are taking the dot product of E. So we got the two equation, H dot grad dot E and E dot grad cross H. So what we will do? We will do equation 1 and this is our equation 2. We will minus equation 1 minus equation 2. We will do equation 1 minus equation 2. And if we do this equation 1 into equation 2, we will get H dot grad cross E minus E dot grad cross H is equal to what we will get? We will get minus H del B by del T minus E dot J minus E del D by del T. So this is our new equation. Now this side and this side we got. So we can also write like this, minus H del B by del T plus E del D by del T minus EJ. Now you can see that we got some compact form. What is the compact form we got? We got H dot grad cross E minus E dot grad cross H is equal to minus H del B by del T plus E del D by del T minus E by J. Now we can also write, I am writing here actually with the another ink. We know that the grad cross A dot B, grad cross grad dot A cross B, grad dot A cross B can be written as the first A B is fixed, grad cross A minus, now A is fixed, grad cross B. So here also we can see we got grad cross E, H is fixed, then E is fixed, grad cross A. So we can write here that this equation can be written grad dot E cross H, or E is similar to H and H is similar to the B. So we got the equation grad dot E cross H is equal to minus H del B by del T plus E del D by del T minus EJ. So this is our new equation. So we are rewriting the equation grad dot E cross H. What is E grad is equal to E cross H? E cross H is equal to minus H del B by del T plus E del D by del T minus E dot J, where E is equal to electric field intensity and J is the current density, E dot J. These all are the vector quantity. Now we know B is equal to mu into H. So we can write mu, I am writing del by del T. H means B is equal to mu H. So we are getting H square plus del, again what is D? D is equal to epsilon E and B is equal to mu H. So we can write mu naught delta H square delta square is equal to epsilon naught. And why we are taking epsilon? Because it is in the free space, and we discussed earlier that in the free space mu is equal to mu naught and epsilon is equal to epsilon naught. So we got del D square by del T is equal to E dot J. Or we can write it mu naught we are taking inside. So del by del T minus H into mu H means H into B minus del by del T. Again we are taking the epsilon 0 inside. So D dot E minus E dot J. So we got grad dot E dot H, grad dot E dot H is equal to this equation, grad dot E dot H. Now what is the meaning of the grad dot E dot H? Grad dot E dot H, if we take the volume integral both side, if we take the volume integral both side, we can get it integration of we are taking the volume integral of the both sides. And what is the volume integral means? Grad dot E dot H is nothing but the surface integral. We can change it into the E cross H ds, because according to the divergence theorem, if it is the we are taking the volume integration both side, then it can be changed into the according to the divergence theorem from volume to surface integral. So we can write E cross H ds is equal to the total line. So what is the value of the meaning of the E cross H? E cross H is nothing but the Poynting theorem P dot ds is equal to, we are getting the total equation. So this is known as the Poynting theorem. The energy we can calculate the energy using the Poynting theorem. Poynting theorem is used to know the energy coming from the outside is equal to energy coming to the inside. Next, already we have discussed the electromagnetic wave equation in the free space. So how to get the electromagnetic wave equation in the free space? We can write grad cross E is equal to del B by del T. So we can also write, we can take the grad in the both side, and we got grad cross E is equal to minus grad del B by del T. Again A cross B. So what we can write? Grad is fixed, grad of the second one minus E is constant, grad cross is equal to minus grad cross del B by del T. Now according to the assumptions or modified Maxwell's law, in the grad cross E is equal to 0. So we can write it is 0. So we can write and the total discussion has been done in the previous class, and if we put the value, we will get grad square E is equal to, what is grad square E? Grad square E is equal to C square del square E by del T square. If we solve this equation, already we have discussed the wave equation in details in the last lecture. So if you go for the details, you can get the proof. Grad square E is equal to c square del square by e square. So we got the what is E? E is the intensity. What is C? C is nothing but the speed of light is equal to 1 by square root of mu silent and epsilon naught. So we will discuss the skin effect. What is the skin effect? The phenomena of arising due to the unequal distribution of current over the entire cross section of the conductor being used for long distance power transmission line is referred as the skin effect. So what is this? We know the general tendency of the electric flux is to stay on the outer side, and inside the number of charges is 0. So the phenomena of arising the unequal distribution of current or charge over the cross section, if we think the cross section of a conductor, inside the charge density is almost 0 and the outer layer the charge density is high. So there is this effect is known as the skin effect. Such phenomena does not have much role to play in case of the very short line. If the short line is there, there is no effect of the skin effect. But skin effect increases considerably when the length is for a long line. The distribution of current over the entire cross section of the conductor is quite uniform in case of the DC system. And what happened due to the skin effect? The total amount of the current density of the surface is increased, leaving the core deprived of a number of electrons. It increases the number of the inductance of the conductor. So today we have discussed about the wave equation. Then we discussed about the Poynting theorem, Poynting vector, the derivation of the Poynting vector, and the wave equation in the free space skin effect. So this is my today's lecture, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.